So hello everyone. Today I would like to discuss a code of vector addition using the thread. So thread is nothing but you divide the code into smaller parts so that you can do the multi-threading. So each code could operate on the different chunks of data. So let's look into that. I'm using the C++ for this. So the libraries would be the iOS stream, CSD lib chrono for the time, then thread library and vector because I am creating an array which is dynamic, so vector, and then using the space is std and namespace std colon, so chrono, and then here's I have this void function. So array is a void procedure, so void random vector, and I'm assigning a vector pointer to it, and it has a start and end value which is defined inside the main over here. Whenever you're calling the function, this chunk is given, and that particular chunk is the start value and the end value for it. So iterating over the loop and giving the value inside this vector. So we are storing those values, and after that we have another procedure which is the vector addition. So it is passing the parameter v1, v2, v3, and start and end. So all these three things, because this is a dynamic allocated memory for the vector, so we are using the pointers for that. And then v3 is actually storing the value for the v addition of v1 and v2. And then again we have the start and end of the particular chunk that we are dividing and giving a particular thread to work upon that particular chunk. So in the main, we have unassigned long, and we have assigned the size variable to a particular, like we are having an array of this many elements, which is a vector array. And then we are assigning like the number of threads we are going to be using. My PC has, just a second. So the number of cores processors that I have is 16, so that's the limit I can go up to. And this is strand random time zero suggests that whenever I'm compiling the code, it will be generating a random value at the compilation, so no particular value will be repeated. Then other thing is like I had to give them a size, and in addition, though if two arrays are adding themselves, the size of the another array should be the addition. Uh, Actually, the sum arrays should be of the same size. So all three of these arrays are of same size. Then the vector I'm creating threads. Here I have actually declared the thread, not created, declared the thread, and then after that I have started the clock cycle. So here start high resolution clock now. I've started the clock and I'm going to divide the particular chunks, the size with the ultimate size which I have over here, dividing that into the number of threads. So each chunks get a pretty similar value to one another. Then after that for loop, dividing, like it will be giving the start index, so where actually it stands for the first beginning. If you look at the first would be it's actually I would be zero, so first index size would be actually zero, and then end size would be if uh, I for the first would be zero. So if I equal to number of threads, which would be in this case 15, if that the statement is true, which means we don't have any sort of threads left with us. So the ultimate size, the end size would be whatever the size we have assigned over here. But if this statement isn't true, we will be giving the end size to 1 into number of chunks. For the first part, it would be 0, so 1 into number of chunks, whatever it lands upon. The first chunk would be that particular size would be there, and then when we are iterating over to it, so the last size, and this is how it is going to move around. And after that, we are pushing those things inside the random vector. Just a second. Yes. And after that, so we have assigned this and those values to both the vectors, and after that, we have to join the threads. So joining a thread is done like after all the synchronization, we want the threads to join. Then threads are cleared and we have to add those. So similar thing is done here, dividing those times again and again and giving them to the vector addition. And after that, it stops. We have stopped that clock and calculated the duration. So it would be nothing but stop minus the start part and then the time taken, and then we are deleting the pointers. So let's compile our code. Plus plus. File name is puzzle.cpp. Let's go with the out. Free thread just because we are actually working with threads, or I could just write thread. So the time taken for how many elements I have written, 1, 2, 3. Just a second. Let me just introduce. I know what I'm working with. So 100 million elements for the first time. That's a big array. Let's go with something a little smaller this time. And let's see what kind of time duration we'll be getting. So this time I have 100,000 elements. Let's compile our code. Output the video. So as you can see, it has taken much lesser time. Let's just reduce the number and see for the 1,000 elements. Let's go with the, you will be observing something as I'm decreasing the vector size. Let's compile it. It is due to the number of actual processes I'm using. So processes seems to be around 16, which means like I am dividing the code into so many different threads, and when I am dividing them into so many different threads, when it comes to joining those threads where the synchronization part comes to play, the overhead is there. So whatever the time it takes in between the communication of all those threads, if I have lesser number of threads, it will be taking much more. It will be taking much lesser time. So overhead would be less. That's what overhead is. So if you look around, in case of the 1,000 element and 100 element time frame, it doesn't make sense. It has more overhead. So let's go with our 100 million elements for now and change our thread size to be 4. Let's see, will this be any progress? I'll just compile this one because I haven't saved it. It's taking much time, so it should be slow, probably. Or there could be a reason due to the stack overflow. Let me just count the number of digits. One, stack overflow. I had to quit it. let's just quit it, stop executing it. I resulted in Stack Overflow because I didn't check the number of elements that I used. So now I think it should be able to compile and execute. There you go, but it has taken much more time than I had 16 cores. Let's go with 10 cores. Let's see whether 10 core is more effective than the 16 core. I think it is. Let's go with 8 cores. So 10 core is better. Let's go with 12 cores. Maybe that's way better than the 10 core as well. Oh, so 12 core is better. Let's go with 14 core. When I'm saying cores, I actually mean threads. I just use the word interchangeably, but that isn't the case. So 12 is actually far more efficient than the 14. Let's go with 13, and we would be having a winner now. Okay, so yeah, 13 core, 13 threads are the winner for my system. So that's how you do it. Thanks for watching the video.